Hi, hi physicists. Here is paper one, 2018, June. Let me go back to the front page. Yeah, this is paper one, 2018, and then May, June. Yeah, it's 150 mark paper. And then today I'm just gonna be doing a really quick the equations of motion, um, covering paper question two of paper one. So let me just clear everything out. Let me clear everything out. Where's that rubber? Yeah, that should do it. That should do it. That should do it. Okay, that should do it. So I don't have two screens here, so I'm just gonna be working on the screen and populating it with the calculations. So yes, first thing you gotta do is let me choose a bright color here and see if yeah, bright enough. Let me clear it. Choose it again. Yeah, it's perfect. So yeah, now let's do question two quickly, and then yeah, for this today's video we're just gonna do question two. So yeah, block P of unknown mass is this one here. All right, it's this one here, is placed on a rough horizontal surface. Rough horizontal surface, it means this is the surface they're talking about, and there is friction F. This is friction here, no matter how bad it looks. It is connected to a second block of mass 30 kg. This is the block here, by a light inextensible string. So light inextensible string actually means we're gonna disregard the mass of the string as well as uh, whether it stretches. So the string doesn't stretch or does have mass. So if when we calculate, we're not gonna regard the mass of the string as well as whether it stretches or not. It remains the same length throughout. So you're just gonna disregard all of those elements, all of those two elements, stretching and mass. That's what this keywords light inextensible string, light inextensible mean. And then passing over a light frictionless pulley, so the pulley as well, we're going to disregard the mass and friction experienced by the string on this pulley because they said it is frictionless. Okay, so now the first thing we do, let's go back and read another statement. Initially the system of masses is held stationary. That means initial velocity is equal to 0 with the 3 kg block. Okay, both of them are a system now. A system means this block and this one are connected, they move together. If you move this one, this is gonna move untouched. So that's why they call it a system. A system is a group of two or more objects joined together moving as an item. All right, above 0.5 meters above the ground. Okay, this is the height, we see it. And then this is here is our displacement, is our changing x. So at this point is y is equal to, is our initial, let me wrap this out. At this point here is our initial height, at this point here is our final height, then yf. So that's why change in I'm sorry about that, it's not changing y, it's not changing x, it's changing y. So changing y, initial height is here and final height is this. So all in all we call it changing y. Changing y is equal to 0.5 meters unless stated otherwise. So yeah, the next thing and strikes. Alright, when the system is released, the 3 kg block moves vertically downwards, so it moves in this pattern and hit the ground after 3 seconds. 3 seconds is our time. So ignore the effects of air resistance. that means we're not gonna include air friction. Air friction is gonna be disregarded. Disregarded. Oh my god. Disregarded. You all can spell disregarded when we're gonna ignore the effects of air resistance when we calculate our when we do our questions. So now define the term acceleration in words. In this case, they said you must do it in words. Sometimes they don't specify, so we can always do it mathematically or unless stated otherwise. So here they stated we do it in words, but we know that our acceleration is equal to change in velocity. It's the rate of change in velocity. Rate, it means always over time. How much does a velocity change over time? So if we have a function, if we have a graph that looks like this, and then we have our y axis here, we have our axis here, we have our origin here, and then we have a graph. Let me change color here and make it like blue, and we have a graph that moves in this direction. It's gonna be the gradient of this line is our acceleration. So in physics, in mathematics, we would write it in this way. We would write something like y is defined by mx plus c. But note that c is 0 in this case because our graph cuts through the origin, and also that our gradient, the gradient of this line, the slope of this line is our acceleration. So in physics we do it this way. We're gonna have our y being change in velocity, and then our x being change in time. How much does velocity change per in a certain time? So we can see that in our case here, acceleration changes constantly as time goes on. So as time goes on, we have our velocity changing constantly. So this is our Pythagoras triangle. This is our velocity, this is our time. So acceleration is the gradient of this line. Yes, I hope the definition is clear now. So acceleration is rate of change, is the rate at which velocity is changing. So that's your acceleration now. All right. So all right. First, the first. Okay, calculate the magnitude of the acceleration of the 3 kg block using equations of motion. So if you recall from grade 11, we did the equations of motion. Equations of motion are written in this way. You have your v final, which is final velocity, being equal to initial velocity plus um, acceleration times time. So this is your time element, this is acceleration, and this is your initial velocity, and this is your final velocity. So we are looking at just the 3 kg block, and we want to calculate the acceleration of this block. So the first thing you gotta do in physics is to always draw a free body diagram. So our 3 kg block is like this. Let me change color here. It's like, let me make it yellow. Yeah, so this is our 3 kg block, and then here is our 3 kg block, and let's look at the forces acting on it. So if you want to understand the forces acting on the 3 kg block, first you must understand why it's in the air, what's keeping it uh, uh, um, hang here in the air. So you're gonna understand there's a tension force because there's a string that's attached to this and it keeps this thing from falling. So the first question is, what keeps this object from falling? Is tension force. So there's a tension force acting in that direction. It's T. And then also, if we were to cut this tension here, if we were to like snap this rope here or string, what will make this object fall? It's gravity. Please, these lines are supposed to be straight. So this is our gravity. Let me just call it F and G. All right, and you must remember that Fg Fg is equal to G. So our gravity is equal to the mass times your gravitational acceleration due to gravity times your mass. So this is your Fg here. All right, let's come back to question. So what you're gonna do is you have first equation of motion looking like this. We don't have final velocity in this equation. We don't have the initial. We have the initial velocity because we were told the object is held stationary. In other words, it's not moving at this point. So initially it's not moving. Initially is the word that's being used here. It's not moving, so initial velocity is equal to 0. At a is the plus acceleration times time. So acceleration is the one we're looking for, and then time we have. So we can't, here is 0, we don't have this. So if we're gonna substitute 0 here and this we don't have, we're not gonna be able to calculate our acceleration because we'll be having two variables. So let's check another equation of motion, which is change in y is equal to initial velocity times time plus 1 over 2 g times time. Please note that when we use y here, we can use g because our object is falling in a vertical direction. Our movement of the object is in a vertical direction. But because it's attached to another object, that means this g, we're gonna make it a. So we're gonna have like, because they are a system, that means if this other object falls, it's gonna move the other object that's on the table. So we're gonna have y being equal to v I t plus 1 over 2 a t squared. I forgot the squared here. Please always make sure that you use your formula sheet so that you don't forget, you don't make silly mistakes. All right, so what we're gonna do here is we have our y here, which I've already defined is 0.5. I'm just gonna write it here, is equal to initial velocity. We already know it's 0, so I'm just gonna put 0 here. Time is 30 seconds plus half of acceleration times 3 squared. So doing your math here, I don't need to even go to the math. You would notice that you're gonna have 0.5 being equal to, this is gonna be give us 9 half being equal to 4.5 is half of 9 times a, and then your a, we know it's 0.5 divided by 4.5, and then if you check it on your calculator here, you're just gonna say 0.5 divided by 4.5, and you get 0.111, which will cap it at 0.11. So your acceleration is equal to 0.11 meters per second squared. So you're done with your acceleration. Please note these zeros. You know them. You know the math. So I won't have to. I won't emphasize on that. But if you want any more math videos, you must please request them in the comment section. In the comment section, I'm gonna do any of. Please request any chapters you want me to cover so that I can know which one to touch, and I'll bring it to you. So next thing we have the tension in the string. So they didn't specify whether you must use they didn't specify which equations you're going to use, or so you're just going to do second law of motion, which is defined this way. You're just going to use the second law of motion, by the way, is equal to um, A, and then you know that um, before you can use the second law of motion, let's go back to our free body diagram which we defined here. We first have to check the direction in which the object will fall, which is this direction. It will fall this direction. So we're gonna say Fg minus T. So Fg minus T is equal to MA, but we're looking for T. So we're just gonna say Fg, which is mg. Fg is equal to mg minus ma is equal to T. We're looking for tension in the stream. So this is your T. Then m is equal to the mass of the object, which is 3, and then we know g is equal to 9.8. All right, and then minus m, which is 3 as well. Acceleration, we have it here, is 0.11, and then you're gonna have your T in newtons. So T basically is equal to all of these in newtons. I won't go through the mess of calculating these because you already know it. You can use a calculator and find this answer here. So I won't compute this. Alright, so the next thing we have the magnitude of the kinetic frictional force experienced by block P is 27 Newton. So we are aware that there is a friction here. Now it's kinetic frictional force. It means this system now is moving. So they told us the friction is how much? 27 newtons. Now draw a labeled free body diagram for block P, and it's kept at 4 marks. I'm just gonna clear my screen a bit just so you can see. I'm sure you don't need this. Alright. Can you clear a bit for the window? Alright. So we are told that we're supposed to calculate free body diagram for block P. So let's go back to block P. So let me clear some other stuff as well, yeah, so that we can make this thing. Alright, so block P, before you calculate anything, we're told to do the free body diagram. So what you're gonna do is, this is your block P, and then block P experiences frictional force. So if the direction is this way, if this one is going to fall this way, block P will go the direction. So it's going to experience a certain frictional force on the surface it is already covered. So in other words, we're going to have tension force being that way. Tension force is the same as this, and then this is block P, and then you're going to have frictional force. Frictional force opposes motion all the time. Always it goes in the opposite direction as the system. So whenever the system is saying we want to go the direction, it will always pull back. It will always pull backwards. So also you must know that the object is set on a table, so it's gonna experience a normal force. Oh, that was a bad line for a normal force. Alright, so let me change color here so that it's clear. It's gonna experience a normal force that is in this direction. Please note that these lines depends on the magnitude of the force. So the smaller the line, the smaller the magnitude. But in our case, we don't have anything to we don't stick to those rules. But anyway, also this object has gravity acting on it, so it's just gonna be Fg, because gravity is the one that's keeping it on the table. Everything experiences gravity. Yeah. So this is essentially what they wanted us to do, and it's 4 marks, just 3 marks for all of these. So you're gonna get a mark for every force that you do. Let me use a green marker here. You're gonna have mark for these, mark for these, mark for these, mark for these, and then you get full marks. So this is your object. Make sure this dot is clear enough. All right. So calculate the mass of block P. So we want to calculate the mass of block P. Block P, remember that it has an unknown mass, but it has mass, but it was unknown. So now we have to work towards calculating it. So mind you, in physics they asked you to draw a free body diagram. After that, you will use this free body diagram to draw to calculate other stuff. So what we're going to do is, let's use our free body diagram to calculate the mass. Where am I going to do this? Okay, let me do it here. I'm sure you guys already have this done. All right. So what we're going to do is we want to calculate the mass of this object. So we're going to use Newton's second law of motion. Is equal to a, and we know that the object is moving in that direction, so we're gonna say forces going in the same direction as the object minus forces going in the opposite direction. Why are we considering only the blue part? It's because the object is moving horizontally, so we are only considering the blue part. So we're gonna say T minus F is equal to ma, and then the T, we already being, alright, we're not told what T is, but you already know that T from the question before that was kept at this. So I'm just gonna compute this thing a bit faster so that we can know the value of T. And then you're gonna say it's 3 by 9.8 is equal to, and then subtract 3 by 0.11 is 0.33 is equal to, so our value of T is 29.07. so our tension is equal to 29.07 newtons. Yes, so we're gonna come back here and compute the value of T, which is 29.07 minus friction. They just told us is 27 newtons, minus 27 is equal to the mass of this block, which is m, and then we have a, because this system is these two blocks are a system. Because they are system, it means they are connected, they move at the same acceleration, which we found from this which we found here. So our acceleration is that same one of 0.11, if you remember. So m times this. So if you say 29.07 minus 27, you're just gonna get 2.07 is equal to m by 0.11. So your mass is basically this over that. So we're just gonna say oh, lost my page. So we're just gonna say 2.07 divided by 0.11 and equals that. You're gonna have 18.81 kilograms. So you're gonna have 18.81 kilograms. I hope that's clear enough. So well, that's all for today. We only did this 15 marks. I hope you guys get it in exam or whenever you write your tests or anything. So just make sure you draw your free body diagrams, and then remember your direction or the direction of your motion, and also look for keywords